Let's take a look at rates of change, velocity and marginals. Now, we'll specifically focus on the marginals and the rates of change. Now, just in general, if I'm looking between two particular points here, I don't know, A and B, these are our x values, and then we got our y values. If we're trying to find the rate of change between these, well, our rate of change is our change in y, and I'll put delta here for that, over the change in x. You know, our average rate of change would be f of b minus f of a over b minus a, assuming this is f of x. So that's just our formula. Nothing exciting about it. That's the algebra way. Well, we're going to be looking at the calculus way of finding the rate of change. So let's take a look at our first problem and talk about it. Give c is equal to 200, and then 3x plus 4 square root of x. And instructions say find the marginal cost for producing x units. Cost is measured in dollars. Now, marginal cost is our rate of change. How much is the cost changing with respect to x? Now, we're going to find a derivative to find this, but first I need to have them in the right form. The square root of x I'll rewrite as x to the 1/2 power. And instead of using c prime, I'm going to use this notation. This is the derivative of c with respect to x. Again, it's interchangeable. You have this, you have c prime, they mean the same thing. Now, if you have a number out in front, you can keep the number out in front. It doesn't affect anything. Now, if it's an x, it's going to be different. But if it's just like a number, you can leave it there. And then we'll take derivative of what's inside the parentheses. Well, derivative of 3x is 3. The derivative of 4x to 1/2. Take our power, put it out in front, lower it by 1. So that's going to give us 200. And 3 plus 4 divided by 2 is 2x. And 1/2 minus 1 gives us negative 1/2. Okay, so 200's there, and we don't want negative exponents, so I'll take that down below here. So this will be x to the positive 1/2. Not sure how far they will simplify this one, but I'll put that back into square root form like that. And I'm going to get a single fraction. If you're going to get a single fraction, you're adding fractions, then they both should be fractions. So I'll put 3 over 1. Our common denominator would be the square root of x. So I'll rewrite each fraction with that new denominator. This one already has it. On our first fraction, we multiplied the bottom part by square root of x. We have to multiply the top part by square root of x. So that gives us 3 square root of x plus 2 over square root of x. And they might not have gone that far on their answer. Sometimes it's hard to say. Let's take a look at the next problem. This is find the marginal revenue. We're given a revenue function, which is 60 times 30x minus x to the 5/2 power. And it says find a marginal revenue for producing x units. Now we'll find derivative again. We'll take derivative of r with respect to x. Again, if you have a number out in front, the number just stays. Derivative of 30x is 30 minus, take your power, put it out in front, and lower it by 1. So this would be 5/2 minus 1. Well, 5/2 minus 1 is 3/2. Actually, that's our answer right there. But let me, it might multiply that through. I don't know. I bet they leave it that way. If I multiply it through it, get rid of the fraction here. That's the only thing I was thinking about. Let me do it just to show it. 60 times 30 is 1800. Minus 60 times this. The 2 and 60 gives you 30, so 150. X to the 3/2. There we go. Our next one is to find the marginal profit. So P is equal to negative 0.2 x to the third plus 40x squared minus 132.1 x minus 500. And we want to find the marginal profit. So again, we find derivative. That'll give us the rate of change. It's a generic rate of change that so you can plug in your x and find it at any point. Now, derivative of this, take your power, put it out in front. So put the 3 out in front, lower it by 1. Take your power, put it out in front, lower it by 1. The derivative of negative 132.1x just gives you negative 132.1, and negative 500 drops away. So 3 times that gives us negative 0.6 x squared plus 40 times 2 is 80 x minus 132.1. Now again, what this is going to do is it's not going to allow us to find a profit. This allows us to find the rate of change at a particular point. How much is the profit changing? The original function is what allows you to find a profit at any point. Let's take a look at this one. It says the revenue R in dollars from renting X apartments can be modeled by R is equal to 3x times 800 plus 40x minus x squared. And it says find additional revenue when number of rentals increase from 10 to 11. Well, this right here, I'm going to go ahead and multiply the 3x through because we will need that for the derivative. 3x times 800 gives us 2400x plus 3 times 40 is 120, and then x times x is x squared. 3x times negative x to the third gives us negative 3x to the third. Now, part A says find additional revenue when number of rentals is increased from 10 to 11. So first we'll find out for 10, and then we'll find out for 11. Now I'm going to plug x equals 10 into this. So I got 2400 times 10 plus 120 times 10 squared minus 3 times 10 to the third. And what in the world did I do with my calculator? There it is. Okay. I need that for the next one at least. This gives us 24,000. This is 100, so that gives us 12,000. This is 1,000, so that gives us 3,000, which should give us 33,000. Now this one here, if I plug in 11 here, again, I'm going through, and everywhere I have an X in my R, I'm putting in 11. And let me just plug this straight in my calculator, because 2400 times 11. So I don't think I can do that by hand very fast. Times 11 squared minus 3 times 11 to the third. Okay, 2400 times 11 plus 120 times 11 squared minus 3 times 11 to the third. Okay, that gives us 36,927. Well, that's great. I'm about out of space here. Oh well. Now, a rate of change using algebra would be your change in revenue over the change in X. But always when you're going just one unit like that, this always comes out as 1 down below. So you wouldn't even have to put it. That's 11 minus 10. And top here would be 36,927 minus 33,000. So minus 33,000. That gives us 3927. That's the first part. Find additional revenue when number of rentals is increased from 10 to 11. Now B says find a marginal revenue when X is equal to 10. This is the calculus method. So I'm going to do B up here since I'm about out of room. Well, we need derivative. So I'll find derivative of R with respect to X. This right here. Derivative of 2400X is 2400 plus 120. Take your power, put it out in front, lower it by 1. Minus 3, take your power, put it out in front, lower it by 1. So that gives us 2400 plus 240x minus 9x squared. Now this is that notation, but I could put it back into R prime of x. And what they're asking us to do here, this is a generic formula that gives us the rate of change at any point. So they're asking us to find the marginal revenue when x is equal to 10. So we're going to put 10 in for x. So we got 2400 plus 240 times 10 minus 9 times 10 squared. This gives us 4800 minus, that's 100, 900. So that gives us 3700. Assuming I did my basic math right here, which is always kind of questionable. Let me double check myself. Okay, plus 240x minus 9x squared. 4800, 100, 900, 30. Okay, let's try that again. I obviously can't do basic math. Okay. 4800 minus 900 gives us 3900. So I get for not using my calculator. Okay, so this is our calculus method, tells us the rate of change, and this is our algebra method. Now realize that this can only tell us the change when we're going from one unit to another unit. This right here is specifically giving us the rate of change at 10. So it gives us a much better result. This is an approximate down here, and down here is the actual rate of change at 10. So anyway, that's what you want to do in C. So I know that's kind of garbled how I got that there, but let me save that. What's this called? Rates of change, marginals. BC rates of change and marginals. Page 01.pdf. There we go. And let's look at the next problem. Grab a drink here. Okay. The profit. The monthly demand function and cost function for X newspapers are given by these. So little p is equal to 4 minus 0.002x. And capital C is equal to 40 plus 2.3x. Now one thing I'll point out, 40 is our fixed cost, and the 2.3x is our variable cost. So depending upon how many units we have, we'll have to take 2.3 times the number of units. And says A, find a monthly revenue R as a function of X. And I put the formula here so you'd have it. R is equal to XP. So R is equal to X times little p. So X is just X, and then little p is our 4 minus 0.002x. X times 4 is 4x. X times this gives us negative 0.002 x squared. And that's our R. Now, B says find the monthly profit. And profit, capital P, is equal to R minus C. Oops. Try it again. Okay. Well, R, we just said, was 4x minus 0.002 x squared, minus C, which was 40 plus 2.3x. Now notice the C I put in parentheses around it because that minus has to flip sign of both of those. So that gives us 4x minus 0.002 x squared minus 40 minus 2.3x. Remember, negative in front of your parentheses flips sign of everything. Now I'm going to combine together like terms. I'll put the x squared first. 0.002 x squared. And I think that's 1.7, but let me plug my calculator since I hate decimals. 4 minus 2.3, 1.7. So I've got 1.7x and then minus 40. Okay, and that's B, find the monthly profit P. C says complete the table. Well, the table has capital P in it, which we already found, this right here. But also has some other items we haven't found yet, dr dx and dp dx. So we need dr dx. This is the derivative of r with respect to x. So we're going to take the derivative of r. 4x becomes 4 minus 0.002, and then take your power, put it out in front, lower it by 1. So this becomes 4 minus 0.004x. Now we also need the derivative of p with respect to x. Well, here's p, so I'm going to take the derivative of it. I have negative 0.00, 3 zeros, 2, and then take your power, put it out in front, lower it by 1. The derivative of 1.7x is 1.7. So that gives us negative 0.0004x. I'm like putting an extra 0 here. It didn't look right. Okay, let's try it again. 4x plus 1.7. And we want to build this table. To be honest, this table's best done with Excel. So let me show that. Okay, so we got our x values here, which would be 300, 600, 900, 1200, 1500. dr dx, dp dx, and then p. Okay, let's go back to our formula. dr dx. That's this one here, which is 4 minus. So we're going to do an equals 4 minus 0.004 times, and it's times x. Well, x is going to be B1. So I'll type in B1. And that's going to refer to that cell location. And I'll push enter. Now if I click this cell and I put my mouse in the lower right hand corner and click and hold down and drag to the right, then it gives me those. Now dp. dp was negative, so I do equals negative 0.004 times x, which x was B1, and then plus 1.7. Again, I'm taking that formula, derivative of p with respect to x, and everywhere I have an x, I'll refer to my cell location. Everything else remains as is. Push enter. Now I'll come back to that cell, filled right. You get these. Now profit. Profit's given by this formula. So I got equals negative 0.0002 times x squared. So times B1, and then I'll do char 2 for the squared. And then plus 1.7 times B1 minus 40. And I'm going to fill right. Now when I fill right, and I look at any of these, you'll see that it refers to the appropriate cell. This refers to D1. This refers to E1. It refers to F1. Now this is our actual profit. So you see it went from 290 to 260 to negative 130 and so forth. This right here refers to our change in profit. So this isn't how much profit, it's how much is changing at those particular X values. And this tells us our change in revenue at those particular ones. And where we're headed with this is next chapter we'll actually look at like where's the point you could reach a maximum profit, maximum revenue, so forth. Here what we could do is we could just play with numbers. By putting it into Excel, it makes it so easy for you just to change numbers. Put 400 in. See, 400, I've still got a positive profit. 450, still positive profit. But look at my change in profit. It's going down, isn't it? 460. So again, you can just play these numbers and see. It's the beauty of doing it in Excel is you can see what's going on with it. And that's it for that problem. If you do this in Excel, just print that off and turn that in. The alternative to this particular problem is you take each one of these values, like x equals 300, and you plug it in all three formulas and do it the hideous way. Okay, let's look at our sixth problem. And get my pen working there. You know, and just in case, do I have room? Yeah, I should have room, hopefully. It's a longer problem, I believe. Marginal profit. When the admission price was $5 per ticket, 40,000 tickets were sold. When the price was raised $6, only 30,000 tickets were sold. Assume the demand function is linear, that the variable and fixed costs are this and this, respectively. Find the profit P as a function of X, the number of tickets sold. So if I look at what our points are, this is X and Y. For this problem, the X is the number of tickets sold. And our Y will be mission price, I guess, price per tickets. So you have to kind of read the problem to see what's X, what is X going to refer to, and X is number of tickets sold. Well, the first thing they give us is they give us when the admission price is $5, 40,000 tickets were sold. So they're giving us a point there. Number of tickets sold, 40,000. Eyes aren't very good. And price was $5. So that's 1 point. Then they give us another point. When the price was raised $6, only 30,000 were sold. 30,000 and then 6. Now the first part here, if we go back to our formula, we need our cost function, we got our demand function, and then this right here. Says assume the demand function is linear. So linear means it's going to have like y equals mx plus b. So we're trying to find a line. Now we're given 2 points. Well, what we want for our demand function that's the first thing. That's little p. And they tell us this is going to be linear. This is, let me draw that again. Little p is equal to mx plus b. So we need two things. We need m and we need b. Well, m is our change in y over change in x. And you remember your formula. This is x1, this is y1, this is x2, and this is y2. So we're going to have 6 minus 5, y2 minus y1, over x2 minus x1. So that'd be 30,000 minus my 40,000. y2 minus y1 over x2 minus x1. Well, that gives us 6 minus 5 is 1. 30,000 minus 40,000 is negative 10,000. I'm going to start putting commas there. My eyes are just kind of going haywire when I'm trying to see those. Well, we need B. Well, if we go back to our Y, remember our next step is to plug in the M we just found in one of the points. Doesn't matter which one. I'll pick this one. That's our X and that's our Y. So we'll put 6 in for the Y. M is negative 1 over 10,000. And X is 30,000. Plus B. Well, 30,000 divided by 10,000 is 3. So we got 6 equals negative 3 plus B. Take the negative 3 over. And we got B is equal to 9. So our demand function, little p, is equal to mx plus b. M we said was negative 1 over 10,000. X plus b, which is 9. So we'll come back to that. Next thing we need is our cost function, capital C, and they tell us the fixed costs are variable and fixed are 15 cents and 90,000. So variable is 0.15, so this would be 0.15x plus our fixed costs, which were 90,000. Okay. Now, remember our revenue is equal to x times little p. So we're going to have x times little p here. So negative 1 over 10,000 x plus 9. So that gives us negative 1 over 10,000 x squared. X times 9 is 9x. So we have better read the instructions. Find profit P. Okay, yeah, we do need to find P. P is equal to R minus C. So R, we just said, was this. So we got negative 1 over 10,000 x squared plus 9x minus C, which up here was 0.15x plus 90,000. So that gives us, let's see, negative 1 over 10,000 x squared plus 9x minus 0.15x minus 90,000. Again, the negative out in front of the parentheses flips the sign of all those. And since I'm afraid I'm going to run out of space, I'm going to do it over here. So combine together like terms. So we got negative 1 over 10,000 x squared. 9x minus that, I think it's 8.85, but let me check. 9 minus 0.15. 8.85, yep. I hate decimals. 8.85x, and then minus 90,000. So this right here is our P of x, our profit. Okay, that's part A. Now B says, find the marginal profits when 10,000 are sold, when 30,000 are sold. Well, we need to find our derivative. Derivative of P with respect to x. Well, so we take derivative of what we just found. Take our power, put it out in front, and we get negative 2 over 10,000 x plus 8.85. Which reduces, that's negative 1 over 5,000 x plus 8.85. Okay, so it says find the marginal profits when x is when 10,000 yeah, x is number of tickets sold. Okay, I was thinking they gave us a y, but they don't. Okay, when 10,000 tickets are sold, and find it when 30,000 tickets are sold. Okay, so into this formula, this is our marginal profit. We're going to plug in those values. So I got negative 1 over 5,000 times 10,000 plus 8.85. Well, 10,000 divided by 5,000 is 2, so we got negative 2 plus 8.85. which gives us 6.85. On this one, I got negative 1 over 5,000 times 30,000 plus 8.85. 30,000 divided by 5,000 is 6, so I got negative 6 plus 8.85, which gives us 2.85. Now realize what this has given us. Find the marginal profits. This isn't telling us the profit. This is telling us the change. A change in the profit at these points. When we got 30,000 tickets sold, this is our change in the profit. And when it's 10,000, this is our change in the profit. So let me save that. Oh, I got one page. Did I manage to fit all these on 2 pages, or did I forget to save the last one? Let's see. This ends at 5, or begins at 5, and yeah, I'll assume I did right. Not much I can do about it at this point. And I think that's it for this. Yep, that's it for that section.